Hello, my name is Daniel Bevan. This is my entry for the essay for the second portion of the Code Platoon application. I am 27 years old. I am a cyber operations specialist in the US Army. And starting with the questions here, tell us about a time you had to learn something new. What was it? How did you approach learning it? In hindsight, what would you do differently? So, when I first got to the unit that I'm stationed at now in Germany, there was this device that we needed somebody to learn and become an expert on because it was one of the most important things for our day-to-day operations. It was this portable server kit that allowed us to hook it into basically our customers' networks for doing cyber defense. And it was a very complex system that had been recently built and had a lot of interworking parts and a lot of things related to Linux and cybersecurity software. And I was selected as the person to go and learn about this device and learn how to become basically the expert on it. And I was given the title Master Gunner. I went to this course, and from there, it was pretty much just learn on your own. Everything had to be Googled. I had to write my own documentation for it. And as I'm getting closer to the time when I need to leave, I actually need to go back and I need to train other people and hopefully get them a little bit further ahead than where I started, since I had to pretty much learn everything from scratch. And what would I do differently in hindsight? I think I would potentially start teaching people early so we could have bounced ideas off of each other. Instead, it was pretty much just me by myself, trying to brute force my way through all of the different issues that I ran into. There wasn't a lot of points of contact for me to get more information if I needed it. And yeah, if I had somebody else that I could run some ideas by, I think I would have been able to get over some of the earlier issues a little faster, because something that you really value is a second perspective when you're trying to learn something new. The second question, why are you interested in programming? So, programming I've been interested in for a really long time, since I was about 15 years old. When I first learned about making video games, I really wanted to learn the Unity 3D game engine, and I learned that you needed to know C# programming in order for you to be able to create games. And I dove pretty heavily into that, learning how to make small games, nothing that I've ever released before, just things for fun. And as I continued to learn programming, I started to branch out into things like Python, C++, and then after that, some web development, and including like full stack. And I started to really enjoy the back end infrastructure and setting up databases and stuff like that, and APIs. And that's where I'm at now. So the next portion here is talking about one of the programming questions that I answered. So I'll go ahead and switch to doing that. So the one that I selected was this string challenge. You can see the question here is have the function string challenge with a passed in parameter of string array. Read the array of strings stored in a string array, which will contain two elements. The first, some sort of string, and the second element will be a number ranging from 1 to 6. The number represents how many rows to print the string on, so it forms a zigzag pattern. For example, if string array is coder byte and 3, then this word will look like the following if you print in it as in a zigzag pattern. And the image here. So my initial thought when I was looking at this would be that it would actually need to be printed out like this, but I noticed that the actual return you can see here is it should form a word combining the characters as you iterate through each row. So for example, in this coder byte example, it would be CREOEBTDY. So what that really meant isn't that it necessarily needed to be printed out like this, because the key was only returning this string at the end. What really is important is understanding what depth each of these letters was at. So with that in mind, I started by setting depth to 0 so that we can make a change to that later. And then I created this Boolean for understanding whether we were ascending or descending. So in this example, once we start moving down the zigzag pattern, so C to O to D, this is a descending pattern. And then it starts to ascend after that from D to E to R. So I wanted a way to be able to track that and be able to switch between them whenever I reached the bottom of the zigzag pattern. And then getting the max depth was just taking the second entry in the string here. So 5, for example, is the past max depth. And then I subtracted 1 since the iteration that I was doing started from 0. So it wasn't going to technically reach 5. It would reach 4, but it's still 5 layers. And then here I created a depth chart. So this is an object that I used to store each of the string or each of the characters at a different depth. And to explain that a little bit further, what that technically means is, for example, once I get to depth 0, so that's the very first one, I basically create a key for depth 0, and then I create an array of characters. So for example, in this one, we've got C, R, and E that are all at depth 0. So I create a key and an array of those characters as a value, and then that just makes it way easier at the end for me to combine each of the keys together and to get this string that you're supposed to get at the end. So initially we just initialize it as a empty object just for now. And then here, if the max depth is equal to 0, then obviously there's no reason for us to go through the rest of the logic because there's no zigzag pattern. It's literally just a string straight across. So we just return the string right back. And then that saves us any kind of compute power going through bothering with all of this. And then you can see here, this is the main function, but we're going to skip that for now because that will come into play later, and then we'll explain it as we go. So down here, we go through a loop, and the loop is just going to create an iterator, and then while the length of this loop, or while I is less than the length of the string passed as the first argument in the array, then it will just continue. So then this is when the print letter function is called. Initially, I had it printing the letters, but that, again, like I said earlier, it wasn't really necessary. Instead, it was just necessary to track the depth of each letter. So here, what I'm doing is I'm checking if the depth that we are currently at is already a key in the object. And if it's not, it's going to initialize that key with the current depth and store the first letter in that key. And that's just so we don't get any errors with it saying like, oh, this key is undefined, so it doesn't put anything in there. So otherwise, if this is a depth that already exists, we're going to create a shallow copy, which is what this spread operator here does. It just takes the array, in this case, the value of depth chart depth, whatever depth we are at, and it makes a shallow copy that you can't destroy the original array of, and then it appends the new letter at the end. So now the new value of depth chart depth, so the key of the depth that we are currently at, is the copied array. And if that sounded a little bit confusing, I can create a little example here. So if we go back to our example before of a key of 0, and it has an array, and we have C, for example, so that's the first letter. So once it comes through for the first time, it's going to create the depth of 0 property or key here, and then it's going to store that letter in an array just by itself. So now when we come back through, we're on R. So R is also at a depth of 0. It notices that 0 already exists. So what it does is it comes in here and it creates a copy of this array, which in this example is just C. So now it's made a copy of the array of C. And then it makes an append and adds the new letter to the end like that. And then it will go back to depth chart depth, which is 0, and it'll now set that to this value. So 0 is now C and R like that. So once we've gone through all of the letters and we've printed them one at a time, or in this case, put them into their respective depths, the logic for whether it's ascending or descending is down here. So once the depth is greater than or equal to the max depth, it's going to set it as no longer ascending because now we are, or my mistake, it's going to set it as ascending because we're no longer descending. So once we hit D here, we know that we're at the max depth of the zigzag. We don't need to go any further. So it's going to flip that and say that we're now ascending. So then it will go back through this same print letter function, and it'll do the same things as before, adding them to the proper depth indexes in the keys. And then the opposite is true once we hit 0. So once we hit 0, we know we've reached the top of the zigzag, and then we will just continue on in that pattern until we reach the end of the string. And then down here, this just lets us know that if we are ascending, then depth is subtracted because we're going from, in this case, 2 to 1 to 0. So 2 minus 1 minus 1 is 0, all that stuff. And then if it's descending, then it will be depth plus plus, so it increments it instead. And this is a ternary operator. The downside to ternary operators is they are easier to write out, but at a glance, it's a little bit more confusing. You could see how I had stumbled a little bit explaining that. And it's just because if you write things in if-else statements like this, it's more readable and it's a little easier to explain coming back in. But I also have comments here, so increment or decrement depth based on whether we are ascending or not. And then finally, we're going to get to the return statement, which gets us our actual result and returns it to find out whether we successfully completed the objective. And that's going to turn each key into an array of characters, flatten all of these arrays into one, and then join the characters together to give our solution. So if you don't know what that means, that's basically going to return an array here, which is this object.values. And that's going to be every single value. So what that normally would do is, since this is a object of a bunch of different keys, so in our specific example of coder byte here, you've got 0, 1, 2. So all of these are keys. What this is initially going to return is an array of arrays. So it's going to return an array that contains one array holding CRE, one array holding OEBT, and another array holding D and Y. So what flat here does is it takes all of those arrays and it flattens them into just one array. So instead of having 3 separate arrays of each row, it's now just one of them all put together. And I can give a more visual explanation here. So what it's actually initially starting out as is we have C, R, E, just like that. And then it's going to have another array, for example, O. I'm not going to type the whole thing out to try to not waste too much time here. And what this flattening does is it just comes in and it changes it. So it's now one array that's C, R, E, and O, just like that. And then finally, what join is doing here is it's joining all elements of the array with nothing in between them. You can put a space here, and instead of flattening them all together, they would have a space in between each other, which is a good thing to note if you ever really want to join things by, say, maybe a hyphen. So you could have it spelt out like that. But in our case, we don't want any spaces because that's not the objective. We just want them to be smashed together, just like the output here in the example. So you can see that cat 5 up here returns cat. Or if we actually do the example provided on there to the side, we can put in coder byte and 3. And we can see the CREOEBTDY is the same as this example here. So when we run our test cases, you can see they come back as correct. And once we submit the solution to see if we pass all 10 test cases, as soon as it is done, you will see that we pass all 10 test cases. And this also uses a time complexity of O of n, which is the most optimal. Just basically means that each element is only accessed one time, which will be calculated later. So yeah, that is the solution to the problem and the solution or the programming challenge that I picked to demonstrate.